I am Jonathan Watson,
And I'm Doug Applegate.
and we are part of the CS course at Introduction to Autonomous Robotics, CS 354.
Our project's called the Robot Rendezvous, and this is what we did.
So in our project, we have two robots that autonomously navigate and explore randomly through an unknown environment. And as they do so, they are identifying key points, landmarks that they can use as a point of reference. Until they have seen the same landmark, the same key point, that they agree that they have seen that same landmark, at which point they will go meet up there.
All right, so now this is important because this is a lot of real-world applications. So the idea of having two robots sync their maps, for example, would be very good for autonomous mapping of real-world environments. It would be good for Google Glass if they decided to have people look at landmarks and then compare what they've seen. So, like, if you've seen the same shop and your friend's seen the same shop, they could automatically mark this off without ever actually asking the person to mark it off themselves.
Also, you may need to have robots meet up for tasks such as package delivery, or how maybe in the future two sentient AIs need to just meet up to hang out. So we encountered a number of challenges. The primary area challenge is that we're dealing with the problems of simultaneous mapping and localization, which is a hard problem, and robot object identification and computer vision, another hard problem, and trying to synchronize this data and getting all the compound error associated with it. And this is topped off by the ROS networking not playing well with some of the pre-existing packages to do this. Let's see. I suppose if we had more time...
If we had more time, we'd actually have the maps sync up. What we have instead is just them having a list of landmarks, and if they've both seen the same landmark, they navigate to said landmark.
Yeah, currently the only data that they're actually transmitting between them are the identification numbers of the landmarks they've seen. But in principle, it would not be significantly hard to actually transmit their map data and then use the landmark location so that they could do the geometry and sync the maps up. And I suppose now it's time for a demonstration of our robot.
And here is our demo. Okay, so these two guys are going to randomly search until they see this landmark. Now, these guys will wait a couple of seconds before they start searching. And the one closest to me is just started exploring.
The one's a couple seconds behind, and they watch, but there he is.
Okay, so neither of them have seen the landmark at this point.
Now, neither of them will really make any change in their behavior after seeing the landmark until they both see it. Because until then, it's not a point of true interest.
What you're about to see is our two robots noticing the point. However, what is going to happen is they will both notice it, but only one will go to it. But they'll both start heading to different points. What happened here was that they failed to go to the same point, but they both recognize that they've seen it. However, we do have a working view of this coming up through our robot's eye view. Now what we have here is both robots starting up. What I'm doing at the moment is making the camera larger so you can see what's going on from the robot's perspective a little easier. So right away this one notices the landmark and has it marked on his RViz. Now when you see that purple, that means a coordinate goal has been set. However, this guy actually hits the other robot that's also trying to get there. So what happened was me and Watson pulled these two apart so they could go forward without totally destroying everything, but this is them going to the same point and hitting each other on the way.